Hi, my name's Liliana. I'm the director of the Australian STEM project. Behind me, Contec Australia is using concrete to 3D print a house. We sat down with them to talk about this innovative technology and how it has the potential to change the future of the construction industry. Here's what they had to say.
I'm Mark D'Alessandro, Director of Contec Australia. Been a builder for 20 years. Contec came about because we run a commercial construction business, and even prior to COVID, we had some pretty major labour and resourcing issues and just getting trades, especially Western Australia. It's a huge issue. And then when COVID hit, we started exploring other avenues to deliver projects. And yeah, we came across 3D concrete printing, and it was using an existing technology, being concrete, but via robots. And yeah, as soon as the borders opened, we went abroad and started looking into and investigating other machines and ways of delivering it. We travelled the world, went to a few different countries, the Netherlands, France. We looked at some of the Nordic countries, and we landed on a machine from the Netherlands, which is the machine that we now have. How the technology works, in very simple terms, it's very similar, or identical, to how a retail 3D printer works at home when you're printing out of plastics. It's just like icing coming out of an icing bag on a cake. That's how I explain it to most people. Obviously, we're dealing with some very heavy industrial applications and some high strength materials, but the principle is still the same. You have to load in a file that is actually printable, so it needs to be designed by someone who knows how to slice documents and make sure they work. And then after the executable file is loaded into the software, you simply hit a button and it starts printing, except the material's a lot harder and a lot heavier than just plastic. A day in the life when we're actually printing will be, probably the morning we'll be doing a little bit of 3D modeling and a little bit of essentially drawing what we're going to be printing that afternoon or that day. So we use lots of different software and lots of different suites that are all married together. So we use anything from Rhino through to Chisel, and we use Revit and some of the other industry standard softwares to draw what we're going to be printing. And then come about midday or whenever we're going to be starting to print, we'll go to our yard and load in all the models, the 3D models, into our software and commence printing. That's essentially what we do. We either drafting and modeling or actually printing in our factory or on site. In Perth, obviously the traditional way of building is double brick, and it is more sustainable than double brick. Double brick uses, the material itself is a raw material from the ground, so that's very sustainable insofar as the raw materials, but the life cycle costs in operating and running a double brick home or a double brick building are a lot higher than running a concrete building, because it thermally doesn't perform as well as concrete, and acoustically it performs a lot better than double brick. So there's treatments that you need to apply to a double brick home, as opposed to they're not necessarily required in a concrete home. Compared to double brick, it does exceed what is required under the National Building Code, whereas bricks on their own don't meet that. There are a bunch of factors which affect compliance. For example, how many windows you have, your solar orientation, are you facing north, are you facing west? But generally, strictly speaking, it does exceed what double brick can produce. For example, a project we did in the northern suburbs of Perth recently, without any insulation and using just traditional single glazed windows, so thin windows, it already exceeded the building code. It got 6.5 stars, and then we applied some insulation to the walls there, and we got just over 7 stars in our rating. So it does thermally, superior to double brick. Printing on a suspended slab, the only difference would be, typically you would take your temporary propping out. When you do your brickwork, we just leave the props in. And it's not because anything is going to collapse, it's just because the machine does weigh 4.5 tonne, in a static load, but in a dynamic it can be actually up to 20 newtons, because it can kind of dance. It's on legs, so yeah, just to stop cracking in the slab, because otherwise it may crack. It's a heavy machine. Yeah. It's no different than putting scissor lifts or boom lifts up on a suspended slab. So yeah, just as a precaution, we leave the temporary propping in for whilst you're printing, and thereafter you get rid of it. So, but no thicker, no thinner, standard 200mm slab that we did in tapping. There can be cavities left in there depending on the design. And yeah, the cavities can be left open. As I mentioned, they can be left open or filled with insulation. It's got three benefits. Number one, it creates a thermal break between the outside and the inside of the building there, so it doesn't transfer heat and moisture and cold. It also provides a water barrier. So if something were to penetrate the external skin of the building, for example, water, for some reason, it can't travel inside there because there's a cavity and it can drain. And lastly, it allows you a space to run services, so you can run electrical, plumbing, or whatever you need to run in the building. We've been doing all walls on the projects. There are some walls which, I don't know, it may just be easier to do it and leave it out if it's non-structural, but generally every wall we've been 3D printing. And yeah, it can also do everything outside of structural walls. So we're doing a pool coming up soon. We're doing a whole bunch of park furniture, landscaped furniture, excuse me. And we're doing flower pots. We did 2 flower pots on a project we just finished. So anything that can be drawn, essentially. The limitation is what your imagination or the laws of physics can apply there. So obviously it can't print something which is going to fall over. That's a bit of a caveat there, but generally if you can draw it, it can be printed. Well, the creativity side of it is at the front end, the designs. So there's, for example, we're doing things in construction, which if you didn't look at them from a different lens or a different angle, you wouldn't be able to 3D print them. So a set of stairs, we're printing concrete stairs at the moment. Now they have to get formed essentially flat, but you can't print in mid-air. So we're printing them on their side and then craning them into position flat. So it's kind of laterally reviewing a situation and understanding how you can print this thing and then make it work. So that's one way we've had to get a little bit creative about how we're using things. We're also addressing some of the skill shortages that we've got in the construction market. So the most expensive and complicated elements of construction are vertical elements, so columns, walls, things like that. And we're using our creativity in 3D printing to eliminate those requirements. So we're producing our own formwork out of concrete now, which makes things a lot safer on site for the workers and a lot faster. And then, yeah, so that is also more of an innovative way to handle things, to make things a little bit faster, quicker, and cheaper on site. Haven't had one crack yet. It needs to be cured properly, like normal concrete. So you need to apply either a water, just with a water hose, or a chemical curing agent. So no, but we haven't had anything yet. We've had hoses block because it's been going off too fast and things like that. Like all the standard things that go wrong in a concrete pour, but no, the material itself has been very reliable. Haven't had it fail or anything yet. The instruction that you give it sometimes is incorrect, and it's actually, because it goes at 500mm a second, it's mesmerizing to watch. It's like watching one of those ASMR videos on YouTube, just things going around in circles. You're just watching this thing, like you kind of like have to stop and go, oh, why am I just watching this thing go around in circles? But it's very interesting to watch. And like concrete is boring as hell kind of thing, but like it's really interesting to watch, especially if you're used to concrete like I am, and it's just all square corners and straight up and down. This can kind of curve and yeah, it's fun. It's really fun. We did a park bench last week. We're doing another one this afternoon at 1 o'clock. And yeah, just watching it with an organic shape, and then within half an hour it's ready to go, be chucked on a truck, and you can send it out to someone. It's really, really interesting. The reason why we landed on this machine in particular is because Perth has an affinity for double brick, and part of the issue with introducing new technology is at the front end in design, and getting designers and architects and engineers to adopt to a new technology. Their first apprehension is, oh, we've got to redesign this and we've got to redraw it, and how do we redraw it, and et cetera, et cetera. So we chose this machine because it can print anything that you draw essentially there. So what that's allowed us to do is take double brick designs and just extrude them as they are. So there's no redesign, there's no redocumentation, there's no recertification. You're following an existing design. So it's meant for us that people out there who have buildings or homes which they can't find bricklayers, they can't find certain trades, they've been able to approach us and say, could you please build my house? And with very little downtime, we've been able to start building their home, which is drawn in double brick there. So it's very well suited. It works with all of the standard gauge materials that we have in Perth. So door frames and wall ties, they're all readily available, but they all suit a certain size, and the machine works within those requirements there. So yeah, it's very simple. The standard house is still constrained by everything else that we've got going on at the moment. So getting an earthworker in, plumber, electrician, etc. So to put it in perspective, we completed a 2-story, 3-bedroom home in the northern suburbs of Perth in just over 5 months. And that's a fairly tight time frame, but the walls themselves only took 18 hours to print. So we still had months and months of tiling and painting and all of the standard stuff, which is still constrained and has to be managed in a similar way previously. But the elements that we're controlling ourselves in-house now, being the walls there, downstairs was done in 10 hours, upstairs was 8 hours. So that just puts it in perspective for you. And there's also a whole bunch of knock-on benefits, which we haven't really gone to tell everyone about yet, but because there's a machine working on the edge of a concrete slab up in the middle of the air, there's less of a requirement for scaffolding. If not, there's no requirement for scaffolding. But what that means is you're not putting people at risk, construction is typically quite a dangerous industry. So we're reducing the safety issues on site, and yeah, people can now, so that 10 hours of printing that I mentioned earlier, that was through 42 degrees days. So we had people still working on site. They were under tents, you know, staying hydrated. So we see this technology as being a good way for people who historically have gone, oh, construction's a tough industry, and you know, you're sweating, you're in the sun all day, every day. They can now get involved in construction, which is typically quite a well-paying job, but apply some of their other kind of like knowledge in 3D print, in 3D design, or, you know, most young people know how to design things in 3D now, or at least 2D on CAD, and they can get involved in it and then not be so out in the elements and getting kind of toasted every day in the Perth sun. Having a team with a vast and a varied experience and knowledge base there does assist, but it also helps that you've got someone on the team who's got a construction background, someone on the team is a bit more tech savvy and knows how to model, and then also having people on site who understand the materials and how they perform. Because Perth, whilst we're very used to Perth being hot, it actually does get quite cold, and concrete performs differently in cold weather than it does in hot. So you need to understand how things work. So having a well-rounded team there has really helped. And yeah, so that helps with the problem solving, and also just being able to understand, and having a construction background there has really helped us deliver this there. There are other people in the market who are more, I suppose they're more academic in attempting to deliver this type of technology, and they're not, I'd say, progressing as fast as we are progressing there. So having a construction background there and accentuating what we can do with the 3D technology has really, yeah, accelerated us. I see our industry as being like ripe for younger people to get involved in. As I mentioned earlier, everyone does some form of CAD now at school, or coding, and you know, everyone understands the basics at least of, like, you give a robot a command and it does it. So I really see this as an opportunity for us to A, address the shortages in the construction industry, but B, get younger people re-engaged in an industry which is kind of, a lot of young people aren't really interested in getting involved in. It's very hard work, and you're out in the elements all day. it takes a toll on your body. So this is a really good opportunity for younger people to get back involved in the construction industry whilst applying existing knowledge. And you're also using a computer, which is kind of, they're all familiar with, hopefully. Most younger people are familiar with using a computer and yeah, delivering housing. And yeah, I see it as being a real growth industry, especially for young people. And you know, also female participation in the construction industry is typically around, I think 4%. It's quite low. So again, you're not lifting heavy bags of cement, or you're not having to like hard graft, kind of like hurt your body and things like that. So it's another opportunity to get essentially 50% of the market kind of we're missing out on because they don't want to be involved in the engagement isn't as high. So it's a real opportunity for females to get back into the construction industry, and yeah, we can open up our labour pool. This technology is only here to help. So we're taking an existing technology being concrete, which is thousands of years old, and it's being done now by robots as opposed to being done by a formworker or a concreter, but I don't see it replacing the technology. The federal government set some pretty ambitious targets for housing and how many houses we need, and a handful of robots isn't going to meet that target on its own. It needs to be a concerted effort by the whole market. You know, every bricklayer in town, every concrete, every formworker, we all need to be working together to deliver the goals and achieve the goals that we've been set. I do see a bit of a mixed future for this technology. It'll definitely have its place in the housing market and construction market, but we're also venturing into the marine infrastructure market. So we're talking to a couple of key players in the recreational fishing market. So we're doing artificial reefs and seawalls to stop soil erosion and essentially the effects of climate change. So we're working with some people there, and there's also fish tanks. So some people in the aquaculture industry, we're dealing with them to create fish tanks for generating sustainable sources of fish. And yeah, skate parks. We're talking to a few people about building some skate parks. There's lots of different aspects there. So couldn't really pinpoint one direction that it's going to go in, because essentially the technology is only limited by the designer and what they're drawing. So if you have, you know, a pretty cluey designer who can draw something really funky, the robot's just going to execute the commands that are being given to it and print whatever you've drawn. People getting more involved in STEM and promoting more STEM is a great thing, because we need younger people. Because I don't know when the last time I saw someone who wanted to do concrete or formwork under the age of 40 was. Like, I haven't seen any younger people getting involved in it in a long time. So this is a way for us to rely on that younger pool of talent there, who definitely, I mean, there'd be thousands of people out there who mum and dad were in construction, but they haven't necessarily gone, I want to follow in that direction, I want to go something a little bit different. So it'd be an existing skill set that perhaps their family's always been involved in, but they have shied away from it because for whatever reason. So now they can get back involved in construction, but apply computer skills and yeah, create a career out of it.
Thank you so much to Mark and the team from Contec Australia for sitting down with us. Follow along to hear more local stories about STEM innovations from the Australian STEM project.